There you go.
Okay, thank you. Okay, so we're going to move on to calculating IV drip rates. So I have a study sheet, and that's coming around. It might be on Blackboard. Anybody recall seeing it? Oh, maybe not yet. It says right on the top, calculating IV drip rates. These are practice problems, okay? So think of IVs like a medication order. You have to make sure you have the right medication, which would be the right fluid in the IV bag, and then it has to run at the proper rate, okay? So the doctor will tell you to run it. They can order it a couple of ways. They might tell you run this bag at 100 milliliters per hour, okay? So how do you get this to run at that rate? There's a formula. You just have to memorize it and plug in the numbers. So I'll tell you that in a minute. So they also might tell you, I have a liter bag of fluid here, run this liter bag in 8 hours or 10 hours. It's different orders. So they gave you an amount of fluid and they're giving you a measurement of time, okay? So sometimes you have a pump. Has anybody worked with any of these? Some of you have, right? Worked with the pumps. So here's an example of one. This is an old one, okay? Have you seen these around?
I got to do, I got to help out the nurse today in the ICU.
With a pump like this?
Yeah,
Or was
I
it
got
a
the
different
prime
one?
pump.
This is an old one. They call the smaller ones smart pumps because
Yeah.
now they're much nicer with little computers in there, and they calculate drips, and they have libraries in here. So for ICU, you might have an ICU library, which would be different from the med-surg floor because you do a lot of drips in ICU that you wouldn't do on the units, on the regular floors, or in the emergency or somewhere else. So yeah, so they're pretty cool. But also remember this, even if you have a pump, a human being does program these, okay? So even if I have drips on pumps, I always go back and check to make sure it's set properly. So basically, and I'm giving you the very basics, so when you get to wherever you're working, it might be just a little more complicated. But when you're looking at these pumps, you want to look for, it's going to tell you somewhere in one of these windows, milliliters per hour. So how do you program a pump? Think milliliters per hour, okay? Milliliters per hour, all right? Well, I would go, I guess I'll wait a minute. So milliliters per hour. So if the order says run that bag of fluid at 100 milliliters per hour, that's easy. Once you get your IV pump all set up here, you would just program this in. And really, as students, we're not messing around with these pumps, but I do want you to take a look at them so you know what you're looking at, okay? Well, actually, you know what? I think I can turn it. I think it'll run if I put this. The reason I have the garbage cans are so they run into the garbage can and not all over the floor. So, so that's on. PRI rate means primary IV. So primary IV, because they might have a secondary, meaning like an antibiotic running, okay? So let's say, what did I say, 100. Let's go PRI rate 100. So up at the top here, I don't know if you can see it from there, but I just put in 100. And then the number underneath it asks me how much fluid am I going to infuse at 100 milliliters per hour. So what is the volume to be infused? So this happens to be a 500 milliliter bag. I don't think it's full though. Might be 400. So I don't want it to run that long. I'm just going to, oops, I got to push a button. Volume to be infused, I'll say it's 100 for now. And then you push start. So now it's going to go. Let's see if it's all unclamped, because if it's clamped, say I have the roller clamp on, it'll beep and tell me that there's a problem. Clamped it, we'll see what happens. Yep, Telling me already. Once I clamped it. All right. All right, now on. So now it's going to infuse at 100 milliliters per hour, right? If you have certain IV drips, like let's say you have a patient on a heparin drip or a nitro drip, all of those will always be on pumps, always, okay? Where if this is a hydrating IV, no medication added, it's just for hydration purposes, it does not necessarily have to be on a pump, though the way things are going now, most places are putting all IVs on pumps, but it could be different depending on where you work, okay? So I'll let that run for a minute. But let's say now, this is not on a pump, so I'll take it off the pump. I'll stop it. Stop. Okay. All right, I just turned it off. So what we're going to do is now run this not on a pump. How do I do that? Well, I'm going to switch over here. Let's switch over to this one. So this is normal saline IV, okay? This is how I would regulate it with this little roller clamp, okay? I would open this up, and then when I do that, it's clamped again. When I do that, it's not running yet, but it will in a minute. Oh, there it goes. I don't know if you can see it from there, but it's going drip, 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 drip because it's wide open, okay? So the way we regulate how fast it's going is by moving this, what we call roller clamp, up and down. So how do I know how fast to regulate this in order for it to run at 100 milliliters per hour? Well, you have to plug it in the formula, okay? So the formula is, and that's on your paper there somewhere, you need volume to be infused, divided by time in minutes. So the volume has to be in milliliters, by the way. And then you divide that by time. And this is in minutes. And then you multiply that by a constant called the drop factor. And the drop factor is in drops. Here's an abbreviation you're not supposed to use. GTT. The GTTS. Drops per milliliter. And that's going to, when you plug everything in, you'll end up with drops per minute. Okay? Drops per minute. So the volume in milliliters divided by time in minutes, and then you multiply that by the drop factor. So the drop factor is a constant, and that is on the tubing. Well, the package, the tubing package, okay? So this happens to be a Baxter tubing, which is what this is here, okay? And when you look at the package, and unfortunately it doesn't tell you anywhere on the tubing, you would just have to go to the supply room if you don't know, but you might know if you work at CMH all the time. And up here in the corner it says 10, okay? And up 10 drops per milliliter. So I'll pass that around so you can take a look at it. So 10 drops, 10 of these drops, drop, 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 equals 1 milliliter, okay? And it's different, see how that goes, drop, 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 so approximately 10 of those equals 1 milliliter, okay? So now I'm looking at, let's see, I have a different one here. I did, is that it? Okay. This is Braun, it's a different company, and it says up here 15. So companies, here, pass that one that way, Heather. Companies tend to always have the same, but it may be different. So if you pick up a secondary, here's a secondary IV set, which means I would use it on this little antibiotic here. It may be different, it happens to be the same. It says 10 right there, okay? Or a blood infusion set. I have some blood tubing here. You drip that in. Where does it say? Oh, on this one it says 10 drops, approximately 1 milliliter, so it says so right on here. okay? And this tubing is a lot different because you're gonna administer blood through it versus your IV, okay? And it might be 15, it might be 20, it might be 60 as a drop factor. So you just have to look at the tubing, and if you have a question like that, on a quiz, for example, the drop factor will always be given to you, okay? All right, so you have to know what the drop factor is. I'm just going to shove that in there in case you want to take a look. So all tubings will be different. So let's go back to this one. If you have a calculator, by the way, you can use it. I have one here if you want to use it. Or if you have a phone and you want to pull it out, I don't care if you use it right now. So let's go back and say we've got an IV here. Let's take it from, we've got an IV running and the order says run it at 100 milliliters per hour. So what's my volume?
100 milliliters.
100, right, 100 milliliters divided by time in minutes, which would be 60. You see that? So then you have to have the drop factor. So let's go with 10. And so you plug those numbers in. Anybody have a calculator and doing the math? 100 divided by 60 times 10.
Isn't it
16.7.
No?
What did you come up with?
16.7.
16.7. Did you do it
Divided up
in
to
your head?
17.
Or you just figured it out?
Oh, no, I got it wrong.
You
I'm not
got-
good at
16, what'd you get? Point
16.7.
0.7? So you guys got the same
Divided
things?
up 17.
So you would, you're right, because you can't have a fraction of a drop, I round up when I get 5 or more, or down if I have 4 or less. So 16.7, so that means 17 drops per minute. Do you see where I got that from? So now, I have to take my watch. This is driving me crazy, I have to fix it. There. Okay. So now I have to take my watch and I have to take this roller clamp and now I have to time it. And I want to time it so we have 17 drops coming out of here per minute. You with me? Okay. So it's trial and error. You might have to take it off. I usually take my watch off so I can hold it right here and not have to worry about, something like that. So you just have to do a little bit of trial and error, okay, and time it for 17 drops. Got it? Yes? What?
I've just never
It's not
seen
so
that.
bad.
I've never seen
anyone do that before.
What have you seen them with pumps?
I've seen them without too, but I've never seen anybody.
Yeah.
There's also this little
Yeah, they don't.
thing. They don't have those anymore, depending on where you work too. Yeah, these are what you call dial of flow, and they would go at the very end of the IV tubing here, attach it here, see it only fits one way, so that would go in there, and then this would plug into the IV, and then you twist it to whatever rate you want. And honestly, when we trialed them at St. Pete's, no one liked them. Everyone hated them. So that's why I have a whole bunch of them here, because then they got rid of them. But because no one liked them and they hated them, they wouldn't use them because they didn't feel how accurate they were. But they were trying to use these instead of a pump to see if that would work, but most people didn't like them. But you might run into them, so take a look at this. And all you would do is twist this.
Did you think it was accurate?
Not really. But what you would do is when you have a patient with an IV and you check them every hour. So maybe you come in at 8 o'clock and you say, oh, it looks like he's got 250 left in this bag. And if it's going at 150 an hour, in an hour when I come back, what should be in there? 150, right? So it should be going down by 100 every hour. So you check that, you check the site, okay? It seems pretty easy, but some of these problems are not meant to confuse you, but I think they will. So these worksheets Every question on here has two parts, and it says, one, how would you set a pump? If you had an IV pump, how would you set it? And remember, keep this in mind, if it asks for pump, your formula is milliliters per hour. Milliliters divided by hours, not minutes, hours. How do you set the pump? Milliliters per hour. Okay? So, if the doctor's order says run this IV at 100 milliliters per hour, how do you set the pump? It's not a trick. 100. 100, right? Just like we did here, 100, right? But they might order it a slightly different way and say, give them a liter of fluid. I'm going to make it a little different so it won't come out the same. Give them a liter of fluid over 8 hours, okay? So, a liter of fluid over 8 hours. How would you set the pump? Milliliters per hour. So how many milliliters do you have? 1,000 divided by 8. And you come up with
Per hour.
milliliters per hour. Pump, milliliters per hour. I don't know how you can remember that, but pump, milliliters per hour. No pump, drops per minute. What did you come up with?
125.
125, yep. So how would you set the pump? 125 milliliters per hour. So let's say you don't have a pump, and the drop factor is, let's make it 15. Use your formula and plug everything in. You can do it two ways. It says 1 liter of fluid over 8 hours, which is probably a little bit longer. A liter of fluid over 8 hours. So what's your volume in milliliters? Then you would divide that by time in minutes. So then you'd have to make 8 hours minutes. 8 times 60, right? Times the drop factor, which I said was 15. Anybody come up with an answer yet? Or did you figure out a shorter way to do it?
No.
Not yet.
7.2.
What'd you come up with?
7.2.
7.2? Is that what you got?
I didn't do anything, I didn't get, I
Did-
missed the numbers.
I didn't get
Sounds
that.
right, but I'm not sure. Ooh.
What
I
was,
don't know.
What'd you get?
What did you say the drop factor was?
15. So go do 1,000 divided by, and it would be 8 times 50. Oh, 8 times 60.
480.
480 times 15. Did you get that? So it'd be 1,000 divided by 480. What'd you get?
I got 31.
31? That sounds more like it.
Yeah.
Is that what you got? 31 point something something?
Yeah,
Yeah, but
31.24.
Yeah, so you'd end up with 31. Because you always
Round it
round
down.
on this one. So then you'd have to come over here and time this for 31 drops per minute. What, did you see what you did, Kate? No?
I think I left out a 0 or something.
So that was telling you, run a liter of fluid over 8 hours. So you had to figure out how to run the pump, and you also had to figure out how to do it in drops per minute. So this worksheet is just a number of different problems like that. I am going to tell you one thing. Cross out number 8 because I think it's confusing and we never do what it says to do, like to recalculate and blah, blah, blah. Cross out 8, just leave it out. I don't like the way it's worded. Okay? So I think I'm gonna, that's it. The rest of the time we're gonna do is practicing that and practicing injections. So I'm gonna sign off.
Peace out.
That's a good